The, the next speaker will Mr. Anil Poluro from Trina Solar India. Mr. Annie is responsible for sales in South India. He joined Trina Solar in December 2012 and has been responsible for commercial and technical sales. And he has been handling global key accounts and strategical accounts. He has over 11 years of PV industry experience and supporting a broad base of customers. Now let's welcome Mr. Anil. Welcome.
Hi, good morning, good afternoon. Um, can I share my screen?
Yes, you can. Please.
Yeah, thank you. Hope everybody is doing good with health. Great. I hope you can see my screen. Perfect. Uh, Great. Today, our topic is how this high power and high efficiency panels are helping the solar PV community to reduce their levelized cost of energy, LCOEs, and initial capital costs. So it is an exciting topic because ever since Trina Solar launched a Vertex series panels, this has been a question why Trina Solar is gone to two steps ahead. Why they went directly 200, I mean directly using 210 cells, and how it is going to help the community. That is something which is there in everybody's mind. And here with this presentation, I would like to share with you our experience and a couple of case studies that we have done in two countries in Europe, which are the actual ones. Thereby, you can really feel that how these costs are coming down, how it is helping you to reduce your LCOE. So my presentation predominantly divided into three sections. Preliminary introduction about Trina Solar, and then we talk about this the LCOE calculations, the case studies, and then I stress more on the additional quality assurance or the quality procedures that Trina Solar is offering to the market. So initially, regarding Trina Solar, it is a 25-year young company, which is started in 1997. If you see the growth strategy, we can divide into three sections: 1997 to 1990, I mean 2006. We are predominantly acting as a solar PV company where we have done our major project during that period was 40 numbers of off-grid rooftop systems, which we have installed in Tibet. And from 2006 to 2016, we are into the product driven company in which we are focused on supplying the product to selective overseas countries, and we used to follow those countries where the solar policy is happening, and then where there is an encouragement for solar panel. And from 2006 we have listed in New York Stock Exchange, and 2008 we have started building up our PV park at our headquarters Changzhou in China. And 2012 we realized that the product needs to have a kind of R&D support. So we have our own state key laboratory for PV science and technology. At that point of time, it is the only one which is having with any of the supplier, and which is largest. And we really proud of having that particular lab because it helped a lot from 2012 till date, and it is helping a lot us. And from 2016, 2014, we become globally number one in terms of the shipments, and we maintained the position for next 3 years. And 2017, from 2016 to till now, we call this is as a Trina 3.0 era, wherein in the previous segment we were previous era 2006 to 2016 we were working on product, whereas from 2016 onwards, 2017 onwards, we started looking into the solutions business, wherein we started beyond panel what we can offer to this solar industry. We started working on the trackers. So you can see in 2018 we have acquired a tracker company, Enclave, from Spain. It is 100% owned by Trina Solar now, and we are started working on the energy management services like the iCloud services or the battery energy storage systems like that. And today we are even working on the artificial intelligence and Internet of Things solutions for related to this renewable energy segment. And in 2017, we have launched this million rooftop solar program in China. 2020, we have listed in Shanghai Stock Exchange. 2021, we become a 50 gigawatt of module manufacturing company and 40 gigawatt of cell manufacturing company. This is a brief about Trina Solar. Uh, we are a true global company. When I say the global company, we have our headquarters in Changzhou, from where we work globally, and there are 6 regional offices. The Asia Pacific headquarters, regional headquarters is in China, in Singapore. We have one regional office in Japan, and Middle East, and Dubai. In the US, we have two and one in Europe. As on date, as on March 2021, we have shipped around 70 gigawatt of panels, and we have connected 5 gigawatts. That is our own projects, wherein we have done the project development and we have done the EPC and connected to the grid. Our presence is there more than 100 countries, and there are 15,000 plus employees. I think the new numbers I'm not supposed to reveal because we are a listed company. I think we would be sooner coming with our new numbers pertaining to 2021 total shipments, which will really surprise you. We are a reliable brand. For last 6 years, we are at the top. We are placed at top rank in the Bloomberg reliable brand list, and this is one of the phenomenal achievement that Trina Solar has been doing. And not only in the BNEF brand list, we are also topping the list of PV scorecard, in which some of the top class module manufacturers never want to participate, but Trina has been topping that list as well consecutively for last 4 5 years. And Asia Pacific region, we are the one of the fastest growing company. So far, we have shipped, by 2020, we have shipped around 8.9 gigawatt. By now, we would have shipped around more than 12 gigawatts. And our presence is, our arms and legs are spreading much faster than what we expected, and that is the demand that is required by the market. Uh, Predominantly, we work on three technologies. Number one, Vertex series, which is we call ultra high power technology. We use their 210 technology. That is what we are going to discuss today. And we are also working. We have a small manufacturing capacity of N-type TOPCon solar modules, which is at the moment it is more to do with the C&I segment, rooftop segments. Yes, you can use them for utility segment as well. There is no reservation. And parallelly, we are working on advanced HJT technologies. HJT technologies, you can see our research quantum of work. Already, we are working on more than 860 projects, and there are 20 plus patents have been applied, and there are certifications, all international certifications, what are required are already achieved. But this is a brief roadmap of technology roadmap of Trina Solar. And next, I will go into the crux, the real agenda of this seminar. Why we are working on the high power and high efficiency panels. If you look into the trend, the market trend in 2020, the demand for the high efficiency panels were only 41 gigawatts. 2021, it was jumped. It was almost doubled. It went up to 85 gigawatts. 2029, it is project 2022, it is projected to 129 gigawatts. This is the demand coming from the market. And also, when you look into the growth of the power bins of the panels from 2009, now every 1 year or 2 years, there is only a gap of 5 to 10 watts. Every 3 years, 5 to 10 watts of power improvement on the technology. However, when we launched initially our Batek series in 2020, the power bins were started going up, rocketing like anything with steep growth. We have launched 500 watt peak panel in 2020, and sooner by 2021 middle, we could able to launch our 670 watt peak panel with the help of the module, the vertex, the cells that we are using 210 cell. And this is how the market is growing. And we foresee this trend will continue for a long time, and this technology will sustain for a long time, as we have seen the polysilicon technology a few years back. So what is the ecosystem that you have for this 210M? Because the main apprehension was like when we started giving you high efficiency panel, oh my God, you are only the company who is working on this particular technology. But look at the ecosystem. Look at the companies. They are all working in this particular with this particular model of the technology. There are five wafer manufacturing companies and 42 cell manufacturing companies with 210 mm, and remaining bill of bill of systems, balance of systems, like 36 companies are already participated in this, and they are able to supply the components required for this kind of technology implementation in module level or the power plant level, wherever you want. And there are six testing agencies already equipped to test these panels, and they can, certify the module manufacturers according to the prevailing IEC standards. So here you go. We have the power pins starting from 400-watt peak, which is predominantly for the residential segment. Then 500-watt peak. Then we went on to 550, 600. Today we are working at 670-watt peak. So for every segment, residential segment, commercial and industrial segment, and utility segment, we have the product. You name the segment, we have a ready-made product for you under the Vertex series. And yeah, as I said, we have 50 gigawatt of manufacturing facility, in which the majority of the capacity is built, allocated to the Vertex series manufacturing. So you need not worry on the capacity availabilities. You have all the panels, all the ratings as per your design demand. So, what is the technology that we have been using in this particular model? I mean, Vertex series. First of all, we are using the biggest possible cell. Today, in the market, you will get the largest cell size is 210 millimeters in breadth and width. That is what the cell that we are using. After that, what we are doing is we are, cutting it with the non-destructive cutting technology, so that the reliability of the panel, reliability of the cell will improve over the time during the lifetime of the panel. And for that non-destructive cutting technology, we are using low temperature laser cutting, so that the edges will be cut very smoothly. There won't be any uneven portions, what generally causes the corrosion and degradation of the performance of the cell during course of the module lifetime under the sun. But because of this technology, this innovative technology, your lifetime of the panel is been enhanced. There is no abrupt degradations that we can foresee. And secondly, we are using multiple bus bar. So far, you might have heard 9 bus bar, 10 bus bar, but we are using 12 bus bars, which means your reliability is more, and your the conversion rate, I mean, electron, I mean, the capturing rate is more. You get more power, and the micro cracks are confined to these two bus bars, in between two bus bars, so that there is no hardly any power that you are losing. We are not leaving any space for electron to die. We are capturing it at the moment it generates. That's how the multi-bus bar system works, and 12 bus bar is much efficient as compared to any other method. And also we are using the high density technology. The gap between cell to cell we are managing at zero point 0.5 millimeters. This is something which comes with the experience. Not everybody can do this, because it needs a precise engineering and a great experience with optimization technologies. Trina Solar being in the industry for last 25 years, we can assure you that the technology or the procedures or the methodologies that we adopt in the manufacturing system, that will help you to improve your modules lifetime, and can guarantee you the precise commitments, whatever we are committing to you under our warranty service condition, under our warranty services. So here a small brief comparison, a quick comparison I'm doing here. Our Vertex series 670 watt peak panel, wherein we use 66 half cut cells, and it gives you high power and high current and low voltage. When we compare it with the 182 mm 540 watt peak panel, there is a direct comparison. 540 to 670, there is more than 125 watts power difference. And also when you connect them in string, because because of the peculiar characteristics of Vertex series with low voltage and high current. You can load more modules in series. You can connect more modules in series. Thereby, per string power, you can go beyond 32% as compared to the other technology. That will help you a lot in terms of reduction on your cables, and then the optimum optimization of your mounting structures. Thereby, the consequent effects like the maintenance part or the cleaning part, all those things will show you a lot of impact. The costs will go down significantly, and you will appreciate the fact that you are saving a lot of money during the not only in the capex but also during the operations time. You are going to save a lot of money with the Vertex series, which is high power and high efficiency panel. So here we go. What we have done actually, there are two systems that we have monitored. One fixed tilt and another one is on tracker. One system we worked in Germany, and the system we worked in Spain. And there is another project we worked from Australia, which is in Asia Pacific region. Results are out, which are in line with the numbers that I am showing you now. And sooner you will be having those details as well on Trina Solar, www.trinasolar.com website. You will find those details as well. We are going to publish them. We are almost finished all our works. So that's why I'm not presenting Australia case here. But for the sake of quick comparison, let us look into these two systems. One fixed tilt. When we have compared all the technologies, like we have compared from the 166 millimeter cell, and then 182 mm cell, and 210 mm cell. In the graph, left side of the screen, I mean left corner of the screen, you will see a graph with orange bars and blue bars. The orange bars are contributing from the G12 technology, that is 210 mm cell modules, and blue bars are sorry, orange bars are for 182 mm cell, and blue bars are from 210 mm cell. So the cost saving which is happening as compared to your reference panel of 166 mm cell is like 3.31% when you use a 182 mm cell. However, at the same power panel, 540 watt peak with 182 mm and 540 watt peak with 210 mm, if you use, there is significant gap again. There is, you can save almost 1% of the capex. When you compare the 540 watt peak of 182 with 650 watt peak of 210 mm, your savings per watt peak would be 2 point almost more than a little more than 2 euro cents per watt peak on the fixed tilt. Whereas the same kind of comparison we did on the tracker, on the single axis tracker, there we could see around 1 cent, 1 euro cent of savings on the capex. When we, when we calculated the LCOE, the savings on the LCOE compared to 182 mm on a fixed tilt is 4.1%. The LCOE is reducing by 4.1%, whereas on the tracking system, it is reduced almost by 2%. How these savings are coming, that I am explaining in the next slide. If you see the savings contribution, where we are saving all this in terms of the BOS and all, you can see more or less invert savings on the inverter will be very nominal, because sometimes because of the policy related issues, you are forced to use the same number of inverters of which is equivalent to the AC power that is been mentioned in your PPA or in your agreement. So inverter cost would be sometimes you'll have savings, but sometimes you won't be having savings. But definitely you will not lose anything by using the 210 mm cell. But when you see the savings at the number of strings requirement and number of structures or the trackers requirement, and then the associated cost like the civil engineering cost, if you're reducing the number of structures, you are going to reduce the number of poles or the civil works related to that that structure installation, all those things will be saved. Those costs are significant. So when they're on the fixed tilt, the 2.04 euro cents has been bifurcated. Majority, like more than 1 megawatt is, 1 cent is coming from mounting systems, and remaining are coming from electrical and civil engineering costs. Whereas in the tracking system, majority of the savings are again coming from the mounting and installation equipment, and remaining all coming from electrical and civil engineering. So that is how the savings have been happening, because this Vertex series is a low voltage high current panel. You can load more modules into one string, thereby number of strings are reduced, and cable is reduced, cable run is reduced. So installation I mean the labor required for installation of these panels are reduced, because it's simple calculation. You are using 1000 panels of 540 for a 550 kilowatt panel system, and you are using around 700 or 800 panels of 650 for the same capacity. So your number of man hours is getting reduced, because people are working with less number of components. You're going to speed up the work. So there are many consequential benefits which are, I mean, which are not tangible here. I mean, you are not able to find, but definitely you are going to see them when you implement the projects. Those costs we are not calculating. With bare minimum cost that you can see, you can compare with that estimations itself, you are seeing a significant drop, or the savings and the LCOE, which is benefiting the developer, and which is benefiting the EPC as well, because they can quickly construct the project, they can save a lot of money on the labor and the installation time, and also they can maintain it easily with a minimum amount of cost as compared to 182 mm. That's how the total LCOE is attractive when you use high power, high efficiency Vertex series panels of Trina Solar. So what is the Trina Solar or Vertex family, or the reliability is all about? Number one is mechanical reliability. How the mechanical reliability is superior, I can explain you in the subsequent slide. Integrated delivery solutions. The transportation, we have a new method of packaging and transportation, so that there won't be any damage. At the same time, I mean, you save a lot of money per watt peak basis when you are importing Vertex series panels. I mean, now, since you are all in the industry, you know what is happening with the logistics industry. Day by day, the container costs are going up. So these kind of optimized solutions will make you save a lot of money in the transportation as well. And the electrical reliability. Electrical reliability, if you see our warranty statement for monofacial 25 years and bifacial 30 years, which is industry standard, but we strongly believe I mean, the experience what we are getting, the feedback what we are getting from the market is phenomenally good, and they always feel we should give them less degradation, because our modules are actually performing better than what it is being stated in the warranty document. How this is possible? This is possible because of our the product optimal product design what we have done with the help of our state key laboratory of PV science and technology, which is there at our headquarters. So with their great hard work, we are able to give you a perfectly optimal solution for your projects. And this is all because of our program, our commitment towards the quality consciousness at all stages. There is no stone unturned when it comes to the quality at Trina Solar, because I know I've been there with the company for more than 10 years now, and I know that some of the products will never come out of the laboratory until unless our people are happy with that product, and then only it will come. We won't sell it for the sake of just for a product variety. We sell it to make sure the product is going to perform at the site, and client is really going to get the benefit out of it. So this is a small comparison. What is that we are doing in terms of size? The yes, 210 mm Vertex series 670 panel, 670 watt peak panel is slightly bigger than other companies. But when you compare the power output for the same power output, if you want to achieve with 182 mm panel, the panel number of cells that should be used in 182 mm module is more. So that makes it very difficult because we have an optimum design of 2.4 meters length and 1.3 meters width, which is easy to handle. Whereas when to meet the same power, if you use 182 mm, the length of the panel is significantly high, and the voltage is significantly high. Then you start comparing, I mean, compromising on your designs, and you start compromising on your logistics arrangement. Then ultimately you see there is more money that you are going to put on 182 mm, Whereas when you use 210 high power, high efficiency panel, you are going to reduce your investments. It's not the other way. It is other way around for the 182 cell. And what modifications that we have done is a slight modification in our frame design, which is ensuring more mechanical design, more mechanical strength. To prove our designs are in line with the expectations, we have done certain enhanced tests, the non-uniform snow load test and static loading, hail impact, enhanced dynamic loading, and wind tunnel test, which is worst test that any module wanted to experience. How the results are here. I can show you. On the static load unequivalent, the snow loading, we have used both on fixed and tracker. Before testing and after testing, you can see the EL images. There is hardly any difference on this panel. So the test results have been passed here. And then we have worked on the hail impact. Here, what we have done is, according to IEC, the hail impact test would be done with 25 millimeters of snowball, but we went with 35 millimeters, and we tested on both monofacial panels and bifacial double glass panels. And to our surprise, our monofacial panel has given a degradation of only 0.17%, whereas IEC says 3%, up to 3% is it is allowed, but we are talking here less than 0.17%. Whereas in our double glass panel, we could see half a percent of the degradation as compared to IEC's 3% of degradation with this hail impact test. So here as well, we have passed margin, with very huge gap from the existing standard to our own strong product design. And we have done the dynamic loading. Dynamic loading number, we used to change the load and we used to do it for number of cycles. And there are two methods that we have followed. We have screwed the panels to the structure, and we are also used the clamps. In both occasions, the reference panel 182 could survive only up to 3000 cycles, but our monofacial panel can survive up to 7500 cycles. Whereas the same test on the bifacial panel, when we did, the 182 cell could survive only for 2000 cycles, whereas Trina Solar Vertex series panel could survive up to 4000 cycles. And when we use the clamps, the bifacial panel is withstanding up to 20,000 cycles. Look at the range. The IEC, we are beating the IEC with monofacial 7.5 times better better results, whereas with bifacial we gone up to, with fixed with screw and nut, it is up to 4 times, whereas with the clamping system we went up to 20 times more than the IEC standard. This is the strength that we are talking about when it comes to the quality and reliability at Trina Solar. The final test, what we have done is wind tunnel test. Here we have kept the panel against the wind speed from 1015 kilometers per hour to 230 kilometers per hour, and we have compared the results. When we see the results, the panel which with Trina Solar could go up to 59.54 meters per second velocity, which is almost like 200 kilometers per hour wind speed, which is passed already, whereas the 182 cell panel is already broken when the wind speed gone beyond 130 kilometers per hour. Whereas we even tested up to what level we can go. We have gone up to 62.6 meters per second velocity, and at that point module started shown the shown the damage, indicated the damage till that velocity, which is almost like 230 240 kilometers per hour of wind speed. Module is stay firm and it performed really well. So that's the kind of robustness that we are talking about here with the Vertex series. In the integrated solutions part, as I said, we have used innovative packing methodology. Generally, panels will be packed in horizontal way, but here, because it is a longer panel, we have worked on the optimum design with the vertical planning. With the vertical packing, you can save almost like you can load more than 12% as compared to any other standard panel, which makes you to reduce your logistics cost at 12% minimum. as compared to 182 cells. And we have tested in all aspects. We couldn't find any issues with this technology, and we are closely, as we speak, for every shipment. We have a team who will monitor, who will coordinate with the end client in terms of the arrival of the port modules to the port, and then how they are how they are handling it at the site, and we give them the training how to handle. Everything will be taken care once the modules reaches to your nearest ports. So here some of the pictures I can show you. This is I mean, on right side of the screen, you can see the supporting stand which comes one piece along with the shipment, where you can use to unpack the panels. So there is minimum of manpower requirement. Once you put them, I mean, hold the panels on the supporting structure, you can take one piece to the module, I mean, the mounting structure, and there is nobody to hold, or nobody to wait for holding these panels, because we are giving a supporting structure. This is how the unloading is been happening. Actual site pictures for your quick reference. So when it comes to the inverter, almost all top inverter manufacturers comply with this I mean, with this product. You call Huawei, Sungrow, Goodby, all string and central inverters are compatible with this panel. And tracker compatibility, almost all top, apart from Trina, there are many in alphabetical order, from Architect to Soltigo, Spain. There are all these tracker manufacturers have given the compatibility letters, and these panels are very much suitable for installing these trackers. So as I said, already we have signed more than 25 gigawatt of orders, and more than 10 gigawatt we have supplied, and we are happy to serve you with this new high power and high efficiency technology Vertex series. Whenever you need, please get in touch with Trina local sales, so they will take care of remaining things. Thank you. This would be my last slide. Thank you so much.
Thank you, Mr. Annie.